Good morning. Today we're going to be solving polynomial equations. We're going to start with some polynomials that we are rather comfortable with working with, like x squared and kind of x to the third power, and then we'll move on to x to the fourth and x to the fifth and things like that. We're going to see how many solutions we have. We're going to state how many real solutions, how many imaginary solutions, and then we'll go through and we'll find the solutions. And then at the end, I'll give you some strategies and different steps to take to find your solutions. So let's start with the first one. The directions say solve each equation. State the number and type of roots. So we're going to start with x squared plus 4x minus 21, and that's equal to 0. When you solve it, make sure it's set equal to 0. And then, of course, when we graph it, we'll put it in f of x form so we can see where it crosses the x-axis. Now, I can solve this 5 different ways because a couple units ago, we learned how to solve quadratics. I can try to complete the square. I can graph it, quadratic formula, take the square root, or solve it regularly. I'm going to first check and see if I can factor it because I think factoring is a little easier for us to see. So I'm going to factor this. We'll set up our parentheses. I'm looking for 2 numbers that multiply to give me negative 21 and add to give me 4. So I know I got to put my x's in. If I'm looking for a negative there, let's try plus 7 and minus 3. So let's check ourselves. This gives me negative 21. Check there. When I add this together, that gives me positive 4. I set each of my factors equal to 0. Again, this is a recap. This is from last unit, I believe, solving quadratic equations. We got 5 different ways. Subtract 7 from both sides. I got negative 7. And I got positive 3. So these are our solutions. So you did not have to factor this one. We got 5 different ways. I chose the factor because I knew it could be factored and I thought factoring was easier. If you want to graph it, see where it crosses the x-axis, terrific. If you want to do complete the square, terrific. If you want to do quadratic formula, you guessed it, terrific. There's lots of different ways to solve this equation. I just chose to solve it by factoring. So we took care of the first part. It says solve each equation. Now it says state the number and type of roots. So I can see that there are 2 roots. So 2 roots. And what type are they? Are they real or imaginary? They are real. So there are 2 real roots. So how many solutions tells, we look at our highest exponent. My highest exponent is 2. So there are 2 real roots. Now, they could have been both imaginary, but they're not. They're 2 real roots. All right, let's move on to number 2. I'm going to solve this polynomial equation. I got 2x to the third minus 50x equals 0. I'm going to check to see if I can factor it. However, I also want to show you that you can get the answer by graphing it. So I believe that I've already typed this one in Desmos. So 2x to the third minus 50x. So that is the first one here that I have in red. So you can zoom in and out, absolutely get a better picture, zoom in and out, all that good stuff. However, I'm only concerned about where it crosses the x-axis. So even though this looks crazy, it just looks like lines, I did type in the equation that we're working on, 2x to the third minus 50x. I'm trying to see where it crosses the x-axis. So I can see that it crosses here at negative 5, 0. I see it crosses at 0, 0, and I see it crosses at 5, 0. How many solutions are we looking for? We're looking for 3 solutions. How do I know that? Because my highest exponent over here, my equation, is 2x to the third. So I'm looking for 3 solutions. So lucky us, negative 5 is a solution, 0 is a solution, and 5 is a solution. So when I go back on my paper and write my solutions down, I'm going to say that we graphed it. So graphed it. And we got all 3 solutions from the graph. So my 3 solutions from the graph were negative 5, 0, and 5. And I got 3 solutions here, 3 solutions here, so we're good to go. There's no other solutions that need to be found. So now I just need to label how many and the type of roots. I got 3 real roots. So 3 real roots. Could I have factored this? Absolutely. I'm just trying to show you different ways. So, but this one was easier to graph it because I found 3 real roots from the calculator. So this one was definitely easier to solve if we just graphed it. Okay, number 3. Number 3, 12x to the third plus 100x equals 0. So again, my first strategy, I'm going to go see what I can get from the calculator just to save myself some time. So I'm going to come over here to Desmos. I'm going to type it in. 12x to the third plus 100x. So I've already typed that in. That would be the first one here. Again, you can zoom in and out and get the whole curvature, but I'm not concerned about what this graph looks like. Again, I'm not concerned. I know it's cubic. It's going to go up, down, or down, up, down, but I am not concerned about what it looks like. I am concerned about where it crosses the x-axis. So if I'm looking here, I see it only crosses once, and that one point is 0, 0. Now, this is going to help me a little bit. However, I'm looking for 3 solutions. This is only crossing once. So that should tell us that I have one real solution, and that real solution is 0. And I'm looking for 2 imaginary solutions. So let me go through that one more time. I'm looking for 3 solutions total because it's x to the third. I see that it only crosses once, and that's at 0. Whether I zoom in and out and try to play with it, it's only going to cross the x-axis one time. So that means we're going to have to do a little bit more work for this one when I work it out. So from the calculator, I'm going to say I graphed it. And we got 0 from the graph. So that means I'm looking for my other solution. So we got to go and solve this problem a different way. Let's try to incorporate let's try to incorporate factoring into this problem. So when you're factoring, you need to pull out your greatest common factor. If I'm looking here, I can see a greatest common factor. I can see my greatest common factor is actually 4. So I'm going to pull out a 4 from everything. And I'm going to pull out an x. So my greatest common factor is 4x. How do I know that? Because 4 goes into 12 and 4 goes into 100. So your first step when you factor is to pull out your greatest common factor. So if I take away a 4 and an x from here, how do I get this back? It'll be 3x squared. And 4x times what is going to give me 100x? That's going to be 25. And set that equal to 0. The great thing with factoring is I can double check myself. 4x times 3x squared is 12x to the third, so we did a good job there. 4x times 25 is 100x, so we did a good job there. Now we set each of our factors equal to 0. 4x equals 0, and 3x squared plus 25 is equal to 0. We go through and we solve each one. The opposite of multiply and divide, I got 0 here. And we should get 0 because I got 0 from the graph. So that corresponds to the fact that it crosses the x-axis at 0, and I got 0 when I factored it. So that lets us know we're on a good track. Now I need to solve this. So it's going to give me subtract 25 from both sides. And the opposite of multiplying by 3, I'm going to divide by 3. And the opposite of squaring something, I'm going to take the square root and I'm going to write over here. So the opposite of squaring something, I'm going to take the square root. And let me put that here. So this gives me x equals plus or minus. I have a negative underneath my square root. That means we need to take out I. So I need to take out an I because I have an imaginary solution. Okay, and we're all done. So for this particular problem, I'm looking for 3 solutions because my highest exponent is 3. Some may be real, some may be imaginary, but I'm looking for all of my total solutions. We got 1 real solution, that's 0, and 2 imaginary solutions. I got positive I square root of 25 over 3 and negative I square root of 25 over 3. So there's 3 solutions, right here, 3 roots. 1 is real, 2 are imaginary. And just a little refresher here, imaginary numbers come in pairs. We'll never, ever, ever have an odd number of imaginary solutions. Imaginary solutions come in pairs. So it'll be 2 of them, 4 of them, 6 of them, 0 of them. They'll come in pairs. You'll never have an odd amount. So if I compare problem number 2 to problem number 3, notice when I graph it, it can cross all positive and I can have 3 real roots, so you can cross all at the same time. Or if I compare that to another cubic function, I can have 1 real and 2 imaginary. Let's do one more, and then we're going to incorporate synthetic division into helping us find our solutions. So number 4, I got 2x to the third minus 7x squared plus 3x equals 0. Your first instinct, go graph it, go use our best friend Desmos, and let's see what we can get from the calculator. So 2x to the third minus 7x squared plus 3x is equal to 0. So let's go see what Desmos gives us. So I already typed this in. Let's get rid of this first one, and we are on this one, okay? Oh, okay, so this is a nice cubic function. I can see everything. Not that I need to see everything, but this one turned out I can see everything on my home screen. I'm looking for where it crosses the x-axis. So I see that it's going to cross here at 0. I see it crosses here at 0.5, and I see it crosses here at 3. So I'm looking for 3 solutions because it's x to the third. So lucky us, we don't need to worry about factoring or solving the equation because we got all 3 solutions from the graph. So our 3 solutions are 0, 0.5, which is a half, and 3. So the answer to this is 0, 0.5, and 3. So when we add that back to our notes and our paper that we're writing down, I'm going to say we got everything from the graph. So we graphed it. It crossed at 0. It crossed at 0.5, which I'm going to put in fraction form, but you're more than welcome to leave it at 0.5. And it crossed at 3. So these are our solutions. And let me circle the other solutions from the other problem. So these are our solutions. So how many and what type? We got 3 real roots. 3 real roots. Okay, now let's step our game up a little bit. So let's see what happens if it can't be factored or I can't find everything from the graph. So let me walk you through how to do some of this. Okay, so number 5, we're going to find all the solutions to this problem. So f of x equals x to the third plus x squared plus 9x plus 9. Your first step should be to graph it. So step 1, graph it and see if I can get any real solutions from the calculator. So let's see what Desmos has to share with us. Hopefully it has some good stuff. So let me get rid of this one, and we are on x to the third plus x squared plus 9x plus 9. So again, this is not a straight line. You can zoom in and out so you can see the whole parabola, but I am not concerned about the whole, not even parabola, so I can see the whole cubic function, but I'm not concerned about that. I want to know where it crosses the x-axis. So I can see here that it crosses right there. Okay. So I'm looking for 3 solutions. The graph only gives me 1 solution, and that's okay. So I'm going to use this 1 solution, and I'm going to do synthetic division. Okay, so let's go back. So from the calculator, so from the graph, we're going to make ourselves a note that from the graph, I got -1 as a solution. So we graphed it, and from the graph, we got -1 as a solution. Now, I cannot factor this. They don't have like terms. I can't group anything together. So I cannot factor this. So that's why factoring is off the table. I can't solve it regularly, I can't do the square root. So we're going to use synthetic division. Since this is what I got from the graph, this is going to go in the box. So -1 is going to go in the box. And we're going to do synthetic division. If you need a refresher course on synthetic division, feel free to go through and rewatch those videos, but we're going to go through and do synthetic division. I'm going to line up my coefficients, 1, 1, 9, and 9. We'll draw the line. Okay, so we lined up coefficients. I don't need any placeholders. We're going to multiply, add, multiply, add. So I'm going to multiply, add, multiply, add, multiply, add. We'll write our answer out. It started x to the third, so your answer starts 1 degree below where we started from. So this is going to be x squared plus 0x plus 9. Okay. Now, since I got -1 from the graph, that means your remainder should be 0. If you did not get 0 here, you did something wrong. You need to go back and redo synthetic division. So let's go through that again. I graphed it. What you get from the graph is telling you, hey, this is the solution. Hey, this is going to work out. So if you didn't get 0 back, you did something wrong. You need to go back and check your synthetic division. Now, I now need to solve this equation. It's a quadratic equation. We can try to factor it, complete the square, quadratic formula, etc., and so on. This cannot be factored because I know it's imaginary. I know it's imaginary because when I graphed it, I didn't see any other real solution, so that means everything else is imaginary. So factoring is not going to work. So I'm just going to solve it regularly. I'm going to set it equal to 0. We're going to subtract 9 from both sides. And I'm going to take the square root. So x is equal to, I'm going to take the I out, plus or minus 3i. The square root of 9 is 3, and then I took the imaginary piece out, and that's where I got I from. Again, the square root of 9 is 3, and then I have a negative, that's where I got I from. And don't forget to do plus or minus when you do your square roots. So now I have all 3 solutions. I got 1 from the graph, that was -1. And then these are my other 2 solutions, 3i and -3i. And let's list how many and what type. So I know that I got 3 solutions, got 3 roots. One of them is real. I got that from the calculator. 1 is real. And 2 of them are imaginary. 2 imaginary. Okay. Let's practice another one where we have to do synthetic division. All right, number 6. This time we're going to do P of x is equal to x to the third minus 5x squared plus 11x minus 15. So P of x is equal to x to the third minus 5x squared plus 11x minus 15. Step 1, let's go graph it. So let's see what I can get in Desmos. So get rid of this one, and we are on this one. All right, so this is what this one looks like. I'm looking for where it crosses the x-axis. This is cubic. So down here where my arrow is, it starts to go up. It's a little turn in there, and then it goes up. So this is a cubic function. Where does it cross the x-axis? Well, Desmos will tell me. It crosses at 3, 0. There are no other real solutions on this graph. It only crosses once. So that means we have one real solution. So everything else that we need to find is going to be imaginary. So we're going to use this and we're going to do synthetic division. So let's make ourselves a note that from the graph we got +3 as a solution. So that means when I go work this out and do synthetic division, I should get 0 as my remainder. So 3 is going to go in the box. We're going to line up our coefficients. 1, -5, 11, -15. I don't need any placeholders. It goes 3, 2, 1, constant, so we're in business. Draw your line. First number comes straight down, and off we go. 1 times 3, add, multiply, add, multiply, add. Again, if you got anything other than 0 here, you did something wrong because we already got our real solution from the graph. We're now looking for our imaginary solutions. So from here, we're going to go through and we're going to write our answer. It started x to the third, so my answer needs to start x squared. So this is going to be x squared minus 2x plus 5 equals 0. So x squared minus 2x plus 5 equals 0. Now, I cannot solve this like I did the previous one. Let me zoom out just for a minute so we can see the previous one. The previous one was x squared plus 9. We subtracted 9, took the square root. It worked out. This one, I'm going to have to either do quadratic formula or complete the square because I can't solve it regularly. I can't just subtract 5 or do something like that. So we're going to do quadratic formula or complete the square. No particular reason. I'm going to go through and I'm going to do quadratic formula. So this is going to be, write our formula down, -b plus or minus the square root of b squared minus 4ac all over 2a. So over here, a is equal to 1, b is equal to -2, c is equal to 5. All right, let's substitute in what goes where. So this is going to be negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I'm doing quadratic formula. You're more than welcome to do complete the square. Maybe I'll do one of those. If not today, tomorrow, refresh your memory on complete the square. But we take our coefficients and we plug it into the quadratic formula. Now from here, it's just a matter of simplifying everything. So feel free to use your calculator if you need to. So we're just going to be simplifying everything. Okay. 2 negatives make a positive. So that gives me 2 plus or minus. Okay. This right here is 4 minus 20. That's going to give me -16 all over 2. So I'm just going through simplifying quadratic formula. Okay. The square root here is going to give me 4i because the square root of 16 is 4. So this is 2 plus or minus 4i all over 2. And everything is divisible by 2. 2 divided by 2 and 4 divided by 2. So this is going to give me 1 plus or minus 2i. Now we have all 3 solutions that we're looking for. We were looking for 3 solutions from this problem. I got one of them from the calculator. That was my one real solution. And then I got 2 solutions when I went through and did synthetic division and quadratic formula. So our 3 answers to this problem are 3, 1 plus 2i, and 1 minus 2i. So those are our 3 answers. Okay, let's list out what we have. We got 3 roots. So we got 3 roots. 1 is real, and that 1 real root is 3 from the calculator, and 2 are imaginary. So imaginary numbers come in pairs, just a reminder. So you'll never just have 1 plus 2i. You're going to end up having 1 minus 2i because imaginary numbers come in pairs. In the next video, we'll talk about how to solve problems that are x to the 4th. So that's coming up in the next video.